Um, okay, here you go. Thank you so much, Joe, for the wonderful invitation to come here. There you go. I can start my video. To present here today. It's a really wonderful opportunity, and it's actually pretty much one of the first times that we're going to be presenting data from the games that we have designed together with Cauldron. So the topic of the talk is training cognitive control using a gamified approach, and I'll take you through step by step what exactly it is that we mean by that. In terms of the background, then, what exactly it is that we mean by cognitive control. So this is very much to do with something that we try and achieve each day. That is, reach and manage goals on a short-term and a long-term basis. So we go throughout our day trying to achieve those goals, be it making breakfast or getting some work done in the short term, or slightly more long-term and more ambitious goals, such as trying to lose weight, or climbing the Matterhorn in Switzerland, or even publishing in Nature. So we're trying to navigate our day-to-day in achieving these goals, and to be able to do that, we need to keep focus on the goal, we need to keep it in mind, and more importantly, we need to try and resist temptation on the way of achieving that goal. And that requires us to inhibit impulses that would stop us from achieving those long-term goals. So cognitive control, then, in terms of a more formal definition, supports flexible and adaptive responses to environmental changes in the pursuit of goals that we have in mind. And it's been shown to be incredibly important for a range of other domains and real-life outcomes. So it supports quality of social relationships. It is very predictive of academic attainment. It's strongly related to well-being, as well as mental and physical health. And even more importantly, the extent or abilities of cognitive control during childhood are highly, highly predictive of cognitive control later life, and all those other outcomes and aspects related to cognitive control later in life. So as such, it's a really foundational cognitive skill that's important for a range of domains which are really important for later life success and well-being. Now, given that cognitive control plays such a core role in our everyday lives, there's been a lot of discussion and attempts to try and support cognitive control and improve it through dedicated trainings. So I'll talk a little bit about plasticity and the literature so far on plasticity of cognitive control. So it's a really, really important question, given how important the executive functions and cognitive control are for later life well-being. Now, so far to date, most of the work and attempts to try and improve cognitive control have focused on working memory. So that's the ability to keep information in mind. So, and if we relate this to keeping goals in mind, working memory is very, very important. If we keep forgetting what it is that we wanted to do, then we wouldn't be able to achieve it in the first place. So working memory plays a really important role in all of this. But the evidence has been quite limited in terms of studies on training cognitive control. So it's been primarily focused on working memory. And the basic logic behind trying to improve cognitive control or working memory in this particular case is this, that, we see a very strong relationship in children, for instance, between individual differences or abilities in working memory, so the extent to which we can keep information in mind, and academic achievements such as maths or reading or IQ. So there's a very well-established relationship between the two. And the idea is then that if we try and improve or train working memory, we also ought to see associated improvement in these related domains, such as academic achievement and IQ, but we don't actually see that. So by now, there's a lot of evidence that these so-called file transfer effects are extremely elusive and very, very difficult to get. And this is baffling for a range of different reasons, because we know that the experiences generalize in long-lasting ways in natural learning contexts, so just taking education, for instance. And we also know that executive functions or cognitive control, it can be persistently affected by negative events. So, stress, for instance, that can really impact cognitive control in long-lasting ways. So why is it so hard to really improve and train cognitive control in long-lasting ways? So the main question that we've pursued in our lab is whether improving cognitive control transfers to other domains, and if it does, whether it's also durable. So I'll talk a little bit about the training and go into the actual approach that we use to do this, which is where Cauldron came in and has been incredibly creative and supportive, trying to get this off the ground. So the basic idea is that sort of at the very core of all of this is a very simple cognitive control task. This is called a stop signal reaction time task, where participants are asked to respond to the presentation of a visual stimulus on a screen. Each time they see a circle, for instance, they're meant to press a button. And on some trials, 25% of the trials, they hear an auditory stimulus. And when they hear the auditory stimulus, which is played with a very, very short delay after the visual stimulus, they have to inhibit. And what's interesting is that the delay between the go signal and the stop signal waxes and wanes with individual performance. And the shorter the delay is, the easier it is to inhibit, and the longer the delay is, the harder it is to inhibit. So this is a very simple test which allows us to look at individual differences in cognitive control abilities, but also the fact that there is such a thing as a stop signal delay, which is what this is called. It allows us to use this to actually train inhibition in a really nice and well-controlled and adaptive fashion. So that's exactly what we did. We leveraged this particular very, very simple cognitive task to train inhibition. So we had two groups that trained. One was the cognitive control training, or what we call the experimental group. They were asked to respond to the go signal and to inhibit to the stop signal. That was the experimental group. And then we had a control group, which just trained response speed. So every time they saw the visual stimulus, they pressed a button as fast as they could. And what was really important is that the task got easier and harder depending on how good individual participants were over these over individual trainings. Now, one of the core challenges in all of this is that we need lots and lots of training to see durable effects. So what we went for, we designed a training that lasted 8 weeks in total, and where our participants were asked to train 4 times a week. And to make sure that they actually do this training as well, we had to implement a couple of features. And again, that's where the creativity of Cauldron came in. So first off, we opted to making this gamified. If we present participants with this task, they would get bored very, very quickly. And in our particular case, we were looking at children to sort of increase the impact of all of this. And if we didn't make this in a gamified fashion, interesting fashion, then they get very, very bored and drop out very quickly. So the gamification was absolutely key, and I'll give you a couple of examples how we did this. We tried to make it very variable throughout. We made it adaptive. So as I said, the training got easier and harder depending on how good our participants were. We made it complex and diverse. So I'll show you exactly how we did that. So we presented children with an overarching narrative by telling them that they had crashed a plane. They were a pilot and they'd crashed a plane in the desert. And to fix their plane, they needed to find the sage. And the sage was able to give them spare parts. And to get the spare parts from the sage, they needed to collect treasure along the way. And to get the treasure, they navigated these different worlds. And in these worlds, they were presented with tasks that gave them treasure, but also these tasks were used to train cognitive control. So I'll just give a short video here. So this is just a visual presentation here. This is where our participants were at any given point in the worlds which they navigated. So here they are just about to enter a world, and we gave them a couple of choices in terms of the kind of world that they're about to enter. Before each game, they were given instructions, and here is one of the sets of instructions. So here they were meant to press a button each time they see a rock, but sometimes there would be a gem displayed on the rock, and when that happens, there you go, they were meant to press the button. So that's exactly an indication of a go trial and a stop trial. So we had 8 different games designed like this, and we changed the setting, we changed the context in ways to try and make this interesting and engaging. So what I'm going to present to you now, isn't it fun? I love these games. So what I'm going to present to you now is a little bit more of the methods, and then some of the data in terms of how children actually engage with these games. So we use this training to address what the effect of cognitive control training is on various outcome measures, and whether these effects hold up after a 1-year follow-up. We looked at this in 209 children, from the Greater London area. The mean age was around 9 years. And here's the basic design. We had pre-training of a particular set of transfer domains or training domains. We looked at executive functions, decision-making tasks, mental health and academic achievement, as well as brain structure and brain function. Then children engaged in 8 weeks of the training, and we looked at whether there was any change as a function of the training immediately afterwards, and then 1 year afterwards. Now, we all know what happened a year and a half ago, a little less than a year and a half ago. COVID struck. So we were a little bit flummoxed by this, but again, because all of this was done online, we could navigate this really, really beautifully. And that was a huge plus of having designed all of this in the way that we had with Cauldron. So I'm not going to present you any of the transfer. What I'll show you now is just how exactly children engage with the training, because this is so incredibly exciting and encouraging for a range of different reasons. So first, I'm going to look at the actual amount of training that total. There were 32 sessions that children could have done over their 8 weeks. And what we see here, here's the experimental group, here's the control group. We see really nice normal distribution. And we see that overall children participated in around 18 training sessions. Each training session lasted around 15 minutes. And some even made it right through up until the 32. So that was really, really nice. What's particularly nice is that children in both groups trained approximately equally. So there are no differences between the groups, and that makes it really nice because we can then genuinely compare any effects pre-post due to the nature of the training as opposed to the amount of training that children had engaged in. Another feature that we implemented just to sort of gauge motivation is we had a couple of bonus games. So after each training session, children did training. So what we have here is the percent of children, percent of bonus games that children engaged in. And what we see, around 30% of the bonus games were actually taken up on, which is, again, quite a nice feature that children were really motivated to do more of the training than we had actually asked them to. And again, this is comparable between the two groups. Now it gets better. So we also asked children, so each week we did the training at school, and at school we gave them a little questionnaire to ask them how much they enjoyed the training, how much they liked it, whether they felt they'd gotten better at whatever it is that they were training. So what we see here, the top score is 40. So we summed these over 7 questions. The top score is 40, and here we've got the means. The means are sort of reasonable. I think children were pretty engaged throughout, and it was similar for both groups. And now what's really, really striking is here we see the motivation change over the weeks of training that happened. What we actually see is that both groups seem to increase in terms of their motivation. So even though the training itself was sort of a significant portion of time that they did each week, but children actually became more motivated doing the training. And that was absolutely incredible and really, really surprising, because usually what you'd see, the more you do something, unless it's actually incredibly enjoyable, you'll see a drop in motivation, but we don't see that here. We actually see an increase in motivation, and that's really, really lovely. So again, wonderful, and it's comparable across the two groups. And now what I'm going to show you is just the extent to which the children improved on the tasks that they actually trained during the training. So here we have the inhibition measure, and this is the group of children that did the inhibition. And here we see the ability to inhibit across the different sessions. And what's absolutely amazing is that virtually all children improve on the core task that we wanted to train with inhibition. And we saw exactly the same for our control group. So the children that trained inhibition improved on inhibition. The children that trained on response speed improved on response speed. So with these data, we really are in the best possible position to actually look at our effects and our transfer effects as genuine. It doesn't really matter almost at this point whether we see anything or not. The training itself has worked extremely well in terms of engagement, in terms of motivation, and in terms of improving.
Sorry about that. We don't know what happened. For some reason, the session just ended. You had got to your slide where you were showing us the impact of the training scores on the Ssrt and in your control condition. Can you go back to that slide?
Yeah.
And in fact, there's a question from one of the participants: is what did the control participants improve on the Ssrt?
No, the control condition, their aim was to just get faster, basically, at responding. So the improvement for the Ssrt was only seen for the group that trained Ssrt, and the control participants only improved on reaction time. So they got faster.
Brilliant. Now, why don't you continue from where you left off?
Sure. I mean, it's pretty much done, actually. I'm so sorry. So just want to conclude, the training uptake was really excellent. Participants were very motivated, which even increased over time. Key cognitive functions that were meant to be trained improved. So we're really in an absolute ideal position from which to examine near and far transfer effects. So to reference, the SAGE games are pretty close to perfect to do cognitive training studies with children, which is absolutely wonderful. So yeah, just thanking the lab, the funders, you for your attention, and obviously Cauldron for the wonderful, wonderful, extremely accommodating and patient collaboration. It was yeah, really terrific, and I think these results absolutely speak for themselves.
Yeah, well, you're more than welcome, Niko. The work you and your team do is really extraordinary. Now, I was saying this before you joined in. So many researchers have been trying to measure transfer effects in the lab and have failed to do so for years and years and years. And you have succeeded, or at least we've got the beginnings of a glimpse that you are succeeding. What impact do you think that's going to have on your area of research and related areas of research? What does this open up as for possibilities?
I think so. I mean, I guess the jury's potentially still a little bit out on whether we actually have transfer effects. So I think we're in the best possible position to really examine whether we do. And I think the amount of data that we have collected gives us a huge amount of leverage in terms of being able to understand why the training would be effective, because we've recorded every single session of a participant. We can look at the waxing and waning across sessions. We can look at the fluctuations, and that gives an enormous scope to really explore what it is that potentially leads to and explain transfer effects. So, I mean, I think if we do end up demonstrating that this is possible, I think that'd be just hugely exciting, because sort of on the one hand, showing that children are very motivated to do this. I think there would be a lot of scope to try and collaborate with schools and in terms of implementing this more in the curriculum, both on the one hand looking at positive effects on mental health, but also looking at attainment, but also looking at social abilities and quality of social relationships. I think these are aspects that matter massively to child development. And I think if we do really genuinely show some transfer effects, then the potential for application is absolutely enormous, Yeah.